Hello guys, and welcome to another lecture on database and SQL coding. Today we are going to learn about SQL Common Table Expressions or CTEs. A CTE is a temporary result set defined within a query, and we define these CTEs using with clause. CTEs can be referenced within a select, insert, update, or even delete statement. So why do we use CTEs? Because they improve query readability and also structure of the queries, especially when we are working with complex queries or recursive operations. The CTEs are different by subqueries because CTEs can be self-referencing and also they can be called multiple times within the same query, and in this way they are more useful for recursive tasks. For example, traversing hierarchical data. The CTEs exist only during the execution of the query. However, still, they can enhance modularity and maintainability in SQL programming. In this lecture, we are going to learn about CTEs, how to write CTEs, how to use CTEs, how to use recursive CTEs for hierarchical data. Like the previous lectures, our examples are based on the university schema with several tables like instructor, department, advisor, course, prerequisite, student, teach, section, time slot, classroom, and text. We can see the list of our tables, so select all from the information schema.tables, and we can see here list of our tables and views that we have. I'm gonna start writing basic CTEs. I'm gonna write a CTE to find classrooms with capacity more than 50, and also I wanna list departments in the same building. In order to write the CTE, I start with, then I can decide any name for this CTE. For example, high capacity classroom, right? So I define it as, so the code will be here. The data are coming from the classroom table, right? And in here, I'm interested in building then room number as well as capacity, because I'm going to check the capacity. I need to have a condition, and that is capacity should be greater than 50, right? So this is a city. Now my city is completed. Now I can make some queries based on this CTE that I have defined here. So select from this CTE, and I'm going to rename it as HCC. Then in here, HCC.building, HCC.room number, HCC.capacity. And also the question says, I want to have the departments in the same building. So I need to join this one. So left join with the department, and I rename it as D. But we should have some common attributes between the department and also this CTE that we have made. So select all from department. So what do we have here? Department name, building, and budget, right? So building is common between both of them, right? So as D, then on HCC.building is equal to D.building, right? In this way, I can join my table with the CTE, right? And order by them, sort them, right? So order by HCC.capacity in a descending mode, right? So let's try this one. There is one error from, there should be no comma here. All right, so you can see here, building, room number, and capacity. But I didn't add the department name. So I need to add here the department name, right? So now let's see, we can have all, right? And because it is left join, so we have some building without department because it's left join, right? So the priority is with the city. So in here, we have building, room number, capacity, and department name, and the capacity is more than 50, right? So this CTE filters classroom, then the main query here joins the CTE with the department, and our objective is to find departments in these buildings whose capacity is more than 50. The left join ensures all classrooms are included even their department name is not. So in this way, we can write this query that we find classroom with capacity greater than 50 and also their department name. Next, I'm going to write a code to find courses taught by instructors in computer science in file 2023, right? So in here, I need to write one CTE, and this CTE is going to filter sections for fall 2023, for example, And the main query then join with course, teach, and instructor to get course and instructor detail. So first we write the CTE, and for that one we start with, right? Then we select a name for it, instructor and courses, then as. So then we're gonna write our code here. So in here, we need to have courses, teach, and instructor, right? Select from instructor, and we rename it as I, right? Because we want to find those courses who taught by instructor. So we have to join this one with the teach, right? With the teach, and we rename it as teach. So let's see what are the common attributes between instructor and teach. Select all from instructor, and also select all from teach, right? So run both together. Then you can see here we have instructor ID here. So in here, I'm gonna write on I.instructor ID is equal to T.instructor ID, right? And also, because I want to have course information, so I need to join it with course, right? So let's see, what do we have in here? Select all from course, right? Then run these two together. So between these two, we have course ID comma. So join course as C, and on T.course ID is equal to C.course ID. It means the course ID attribute is common between course and teach tables, right? Then here, what information I'm gonna retrieve, right? So I.instructor ID, it means from instructor table. Then I.name, because the name is not very clear, so we're gonna rename it as instructor underscore name, right? Then from the course, we're gonna have course ID and also course.title, and we rename it as course underscore title to be more clear, right? Also, we need to get course.department name, and also from the teach table, we're gonna get semester and also T.year, right? So this is our CTE. Now we need to write our main query. So select all from where? From this one, from this CTE, where we can add some condition. For example, semester is equal to fall, and year is equal to 2023, and depth name is equal to computer science, right? Okay, everything fine. Semester, okay. Where semester is equal to fall. And also we can order by, we can sort them, right? Order by instructor name and course ID, right? That's all. So let's run this one. Okay, we found it. Instructor ID, right? Instructor name, course ID, course title, department name, semester. In this way, we can filter sections, like for fall 2023 and computer science department. So let's, for example, change this one to 2024 and change this one to biology. Then we can see. So these are the courses that offered in fall 2024. We can also write multiple CTEs in one query. For example, I want to find students who have taken courses with more than 3 credits, and also I want to print their advisor name. For this example, we need to write 2 CTEs. One to identify high credit courses, it means more than 3 credits. Another one, we need to write to find students who take those high credit courses. And finally, we need to write a query to join with a student and advisor to find their advisor, right? So with name it as high credit courses, right? And as select from which table, from course, right? And I'm gonna get course ID. And here is a condition where credits is greater than or equal to 3, right? So this is 1, and I need to close this one. Then I need to define another CDE. So I'm gonna call this one as student courses as, then here select from where, from text, and I will rename it as T, right? Then I need to join this table with high credit courses that I defined here. So let's see, what do we have in here? Select all from text. So I have course ID, right? So join with this one, and I'm gonna rename it as HCC on T dot course ID is equal to HCC dot course ID, right? Then what to have here, T dot student ID and T dot course ID, right? That's okay. No, this one should be common. I need to write the main query, and in here, I will join it with student and advisor, right? So select from student courses, this one, and I rename it as SC. Then I'm gonna join this one with student, and in here we have student ID command, right? Because student ID we got it already. So on sc.student ID is equal to s.student ID, right? And also I need to join this one with advisor because I want to get advisor information as well. So left join with advisor, and in here, so I can rename it this one as A on s dot student ID is equal to a dot student ID. And also I need to left join this one with instructor because I want to get information of the advisor and rename it as I on a dot instructor ID is equal to I dot instructor ID, right? And finally we can order by based on s dot student ID. That's okay. Then in here, what to have in output is dot student ID, then s dot name, and we rename it to not have two names there. So we rename it as student underscore name, I dot name, and we rename this one as advisor name, advisor underscore name, right? So let's see. Very good. Student ID, student name, advisor name, right? So the first CTE that we defined here, this identifies high credit courses. It means those courses which has credit more than 3. Then the second CTE here finds a student who took these courses, right, from high credit courses, right? And then the main query joins with student and advisor table to provide information. So we have student ID, student name, and advisor name. The next example is recursive CTEs with hierarchical data. Recursive CTEs are used for hierarchical or tree-like data, such as course prerequisite. Course prerequisite, it means if you want to take one course, you must have already passed another course. And another course may have another prerequisite, right? So it's like a chain. For example, you need to pass the algorithm course, then you can take C programming course, then you can take C++ course, right? This is called as hierarchical courses. So I'm going to show you one query to find all prerequisite for a course, right? It means direct and indirect prerequisite. For this one, I need to write a CTE, so be it course and prereqs. So in the first CTE, I need to find direct prerequisite for some course, right? So I need to find course underscore ID, prereq underscore ID, and here I will add level. Later, I will tell you why I use this level here. So in here, select from prerequisites and what to have in prerequisites. So let's see what do we have in prerequisite. Select all from prerequisites. So we have course ID and prerequisite ID, right? So I'm gonna get course ID, and also prerequisite ID, right? And one as level, okay? So this is for level 1. Then we go to find prerequisite of this prerequisite in the next level, right? So where I can determine a specific course here, course underscore ID is equal to bio, for example, bio 399. Why bio 399? So let's see here, bio 399 in this table has a prerequisite 301. And then bio 301 has a prerequisite 101. It means one student must first pass bio 101, then must pass bio 301, then he can take bio 399, right? That's why I selected this course. And then in here, union all. All right. Now I'm gonna find prerequisite of prerequisites, right? This is a recursive member. So select from prerequisite and I rename it as P. So in here, P dot course ID and P dot prerequisite ID and CP dot level plus 1, right? Then in here, I'm gonna join this one with course prerequisite as CP on where they are the same in the prerequisite, right? P dot prerequisite ID is equal to CP dot prerequisite ID. Next, I'm gonna write the main query. Select from this one, course prerequisite, this one as CP, and then I need to join this one with course. Join with course, and we rename it as C on CP dot course ID is equal to c.course ID. And again, we're gonna join it with course, and we'll rename it as PC on cp dot prerequisite ID is equal to PC dot course ID, right? Because they are like a chain. And then we can order by cp dot level and cp dot prerequisite ID. So let's try this one. There is one problem. Oh, here I didn't write here. So c dot course ID, then c dot title, and we rename it as course underscore title to not be mixed with prerequisite, right? Then cp dot prerequisite ID and pc dot title. Then this time we rename it as prerequisite underscore title and also cp dot level, right? So let's try. So it means we have made some error here that it received the 100 recursive and it didn't find anything, right? Here, we should not say prerequisite ID is prerequisite. No, in here, we should say course ID is equal to the prerequisite ID, right? So let's try. Okay, so we found that this Bio 101 is prerequisite of Bio 301 and Bio 301 is prerequisite of Bio 399. So I'm gonna explain this code again line by line. This here, we declared a recursive CTE and we name it as course prerequisite. And here we have three columns like course ID, prerequisite ID, and level. Here, select course ID, prerequisite ID 1 as level, prerequisite, and where course ID is Bio 399. This is the base case of the recursion. We select direct prerequisite for this course, right? Like what? B301, right? These are the basic one, right? Direct one, and we name it as level 1. Then in here we made union. We combine the base case with the recursive part that you can see here. This is the recursive part of our CTE. This will find the indirect prerequisite by joining the previous level prerequisite ID, and then they will increment the level by 1 to reflect the depth, right? And in here, our CTE definition has been completed. Then we define one main query, and this query is select the course and its prerequisite details along with the hierarchical level. In here, we join this course prerequisite that we define with course and again course. So it means we join the course table twice to get the title of both the main course and its prerequisite. And finally, in here, we order the result by prerequisite level and ID for clear hierarchical structure. When we are working with CTEs, we should use descriptive CTE name for clarity. And also we should make sure that recursive CTEs have a termination condition to avoid infinite loop that happened for us in the last example. In this lecture, we learned about the common table expression in SQL. Our emphasis was on their value for writing clean, modular, and maintainable queries. We started with an introduction to CTE and learned how to use CTE for filtering and joining data. Then we tried some multi-CTE scenarios for combining multiple logical steps within one query. We then delved into recursive CTEs. These recursive CTEs are particularly powerful for handling hierarchical data structures such as course prerequisite. Thank you very much for your attention, and please feel free to ask me your questions by leaving a comment below this video lecture. Thank you and see you in the next lecture.